All right, so we're going to try to finish up the live coding today and then get you all started on some practice pair programming activity. So where we left off yesterday is we did the set method on this list that we're working through. And where I want to shift you today is to start incorporating some loops. So far, everything we've done is really just to illustrate the methods on the iterator that we can call. Usually, however, we use an iterator in the context of a loop. And so we're going to write a loop together, and you'll see this is like super, super common. You'll do this over and over again. So in the loop, we use the has next method is often used in the context of a while loop. So this little code snippet we're writing, you're going to write over and over again as we do different programming activities. I already have a variable named iterator that refers to the iterator that we've been using. I'm going to reuse the same variable, but I'm going to obtain a new list iterator object so that the iterator moves back to the beginning of the list. It's just an easy way to kind of reset everything. So I'm going to say iterator, whoa, I don't know what I hit there. Iterator equals staff dot list iterator. And then we'll keep using the comment format we were using yesterday with abbreviations of the elements. So we have Diana, Harry, Juliet. Who is A? Albert, and Tom. And the iterator is at the start because I just made a new one. So the vertical bar, the pipe character, indicates the iterator position. So here's how we usually do this. We write a while loop. We say while iterator dot has next. So as long as there are more elements in the list to traverse, the while loop will continue to run. We can do whatever we want inside this while loop. In the various programming activities, you'll do all sorts of different things. Let's just, but usually in the context of while loop, we're going to call next. So let's capture the element we're going to iterate over. So I'm going to say string n equals iterator dot next. So we'll iterate over, and let's capture this. Well, it's going to run over and over again, so I won't add a comment here. So the first iteration of this loop, we'll iterate over Diana, and will be assigned to Diana. Let's say we're searching our list for a particular name. Let's say we're searching for Juliet. We could say if n dot equals. Remember, with strings, we have to use the equals method. We can't use the equal operator because we're interested in, do these two objects have the same sequence of characters? Not, are these the same object, like the identical reference? So if it equals Juliet, cool, we found Juliet. If we find Juliet, let's remove Juliet because we already got rid of Romeo. We might as well get rid of Juliet. Iterator dot remove. There we go. What I'm going to capture here in the comment, though, is when this if statement is true, that means we have Diana, Harry. We would have just iterated over Juliet. So our iterator will be between Juliet and Albert. And then after we call remove, Juliet will be gone. And we're left with Diana, Harry, iterator position, Albert, Tom. When this loop finishes, the iterator will be at the very end. So this little code snippet here is a great thing to go back and reference as you're doing the various practice programming activities because it's such a common structure. Super, super common. You may remember a neat thing about array lists is that you could use an enhanced for loop with your array list to iterate through the elements in your array list. That's not a special feature just of array lists. That works with all collections. So let's do an example of that. That can be super helpful. Enhanced for loops work with linked lists. So we can just say something like for string n staff. And then, I don't know, let's just print it. System.out.println. We'll print the name, and then I'm going to add a space here so they're like spaced out. And then I'm going to do like what the whole like what we expect thing. So first I'm just going to do println to get a blank line. And then I'm going to do print line and say expected. So it should print Diana Harry. Again, if you just want to use their first initials to save typing, totally fine. Whatever works for you. All right, so I know this was a while ago, but there's some limitations when using enhanced for loops. When we're using an enhanced for loop to iterate through a collection, whether in an array list like last school year or a linked list like we're doing right now, what can't we do in the context of an enhanced for loop? There are a couple things, but what's one? We can't modify it, right? If we were, if we were to say like n equals some different name, it's not going to change our list. It's only going to change that local variable, right? So we can't modify it. What else? Can't use what? I'm sorry? Yeah, we don't know what the index is, right? So if we were iterating through here and we were searching for Juliet and then we found Juliet, like we wouldn't know what index Juliet was at because we have no index, right? So that's unfortunate. So those are some of the limitations of an enhanced for loops. And there's one more that you didn't run into last year that we're going to see this year in just a second. All right, now we're going to get into like the new thing as we wrap this up. So what I think is the biggest like technical coding challenge or debugging challenge you're going to run into in the next couple of weeks is concurrent modification exceptions. Concurrent modification exception. Concurrent modification means multiple things are changing something at the same time. That's what we mean by concurrent modification. We are going to write code to cause this exception to happen so that when it does happen to you, you will have some experience with it and recognize why it's occurring. So when does this occur? Well, the rule is we cannot modify a linked list while also using an iterator unless you use that iterator to do so. So the basic rule of thumb is like, if you're using an iterator, use the iterator for everything. Don't use the iterator sometimes and then use the list directly other times. You're going to get a concurrent modification exception. So if you're going to use an iterator, go all in and use the iterator all the time, and you'll be fine. But here's where we get into trouble. So often I see code that looks something like this. So let's reset our iterator. Iterator equals staff dot list iterator. We're going to use the same structure as before. While iterator dot has next. So while there are elements to iterate over, we'll grab it. String n equals iterator dot next. I guess we could just copy this from above. And then I'm going to say if n equals, let's see, who's left? Harry is still here. If n equals Harry, staff dot remove Diana. All right, this is a contrived example, but if we find Harry in the list, then remove Diana. Because as I'm sure you've heard, Harry and Diana cannot be in the same group together. I don't know, I'm making this up. So if we find Harry in the list, we're going to remove Diana. What I want you to do now is once you type this, scroll up to the top, hit that run button, and see what it looks like. And I will do the same here in just a moment. All right. Some of this looks like it did yesterday. We printed Harry. We expected Harry. Here we printed the list. Here I printed Diana, Harry, Albert, Tom, and we expected that. Um, Actually, I meant to print that slightly different, not to sidetrack us, but I'm going to change this to print instead of println because I kind of want it all on the same line. But anyway, and then the new thing, exception in thread main. That's just like the default Java thread that we run when we run our program. We get a java.util. Here's the concurrent modification exception. It tells us where. And this is called the stack, and we'll learn more about the call stack later. But what we can see here is that we're like, this is like java.base, java.util.linked list. When we look at this, we're like, that's not my code. That's somewhere in the Java standard library. That's where the exception was thrown, but that's not where like the problematic code is, okay? Chances are there is not a bug in the Java standard library that we're going to run into. Here is java.base/java.util.linked list. Again, this is not our code, don't care. Here we keep working our way down. List_demo.main. Oh, this is our code. And you'll notice when you hover your cursor over this, it has an underline. And if you control click on that on Windows or hit the Windows key and click on it on the Mac, it will actually jump to this line number 105 and say basically like, here is where the exception occurred. So that makes it easier for us to track down what we did wrong. And what we did wrong in this case is we were using an iterator. And while we were using that iterator, we called a method that modified the linked list directly because we invoked the remove method on staff, which refers to the linked list. And our iterator detects that we did that behind its back, and it throws up its hands, throws the exception, and says like, nope, can't do it. In next chapter, when we start implementing this, we'll see why. But basically, the iterator is like, I don't know where I am in the list, and I don't know where to go next. So I can't safely do anything. And so it just throws the exception. So we can't write code like this. So we're going to comment this out so that you can refer to it, but yet we still want this code to run. All right, we're gonna generate one more concurrent modification exception. This is the one that really sometimes stumps students. So the enhanced for loop automatically creates an iterator. So last year in APCSA, when you were using enhanced for loops to iterate through array lists, you were implicitly using a list iterator, just like we're doing explicitly now. It's all the same. The code that we write up here, like this code right here, these 3 lines of code are identical to and are actually what executes behind the scene when we type familiar code like this for string n staff. This enhanced for loop does this. It's the same thing. The reason why I'm pointing this out is because when we use an enhanced for loop, well, now you know it uses an iterator, but we often forget because it's not explicit. So then we write code like this: if n dot equals, let's equal Harry. Let's search for Harry again. And then we say staff. Okay, if Harry's in the group, we're going to add Charlie. Sure. They were great together. This code looks pretty innocuous. But after you type it, go ahead and scroll up to the top, hit that run link again. I'll do the same. And we get another concurrent modification exception. Now on line 115, it just points to the enhanced for loop because we can't like actually see the iterator at work, right? But remember, like internal behind the scenes, this enhanced for loop is just using a list iterator. And so we get the concurrent modification exception because while we're using this iterator indirectly, we invoke the add method on the stack variable, which refers to our linked list. So we just went behind the iterator's back and changed the linked list. The iterator throws up its hands, throws an exception, and says, we're done. You can't do that. So when you generate this exception, you now have two examples in our class notes that you can go back and refer to. I'm going to comment this out as well, just so it doesn't crash. But you now have two examples that you can refer to, to remind you of like, oh yeah, I can't do that. That's right, I forgot.